We're going to briefly talk about reactions. If you guys remember back to statics, if we are looking at external reactions, we have three. And a reaction occurs when we are resisting movement, translation, or rotation. So we have a roller. And remember, we kind of look at a roller as being kind of like a circle with a line on top. Um, it's like we can think of it as a skateboard. If I stand on the skateboard right there in the middle, nothing happens. So we are getting a y component, okay, that's preventing us from moving down. Now, if I push or pull on that skateboard, it's going to roll. Translation occurs. We don't have a force that's resisting. If I put my little pencil up here and I make it like a teeter-totter, then we're going to have rotation right around that roller. If we have translation, we don't have any resistance. So when we say something is a roller, then it's going to have one direction that we are preventing translation, and it's perpendicular to the surface that we are sitting on. Okay, so remember we kind of talked about last year that we could have a beam if we had a giant bridge girder. Then sometimes a roller doesn't necessarily look like a roller, but it could be kind of a little rubber block. And that way, if the bridge, we have an increase in temperature, then as the girder wants to elongate, we have space. We have a way for this to translate so that we don't build up stresses, but we are always going to be holding it in the vertical direction by that roller type reaction. We have a pin reaction, and a pin reaction kind of signify as a triangle, and you can think of a pin as a door hinge. Okay, if you try to take your door off, you can't pull it off up and down, you can't pull it off like in the X direction, but you can rotate it. So again, we can think of it as a teeter-totter. If I stand right here, nothing is going to happen in terms of translation, so I will develop a y component reaction. Okay, if I try to pull on it or push on it, it's stuck in place because of that pin, just like a door. And so we develop an X component because translation does not take place. Now, if I choose to sit on this side of my teeter-totter, it is going to rotate. And if I have rotation, we are not resisting a moment. Okay, so with a pin, so a roller, we had one unknown. With a pin, we have two. And so we can go back to that same bridge girder, and we've got this rubber bearing that's acting as a roller, so we can allow translation because of temperature changes or dynamic loadings. We are not allowing vertical over here, but we are pinned because we don't want the whole thing just rolling off. Think about it, if we were building on two rollers, that would literally be like building on a skateboard, and that's not very stable. Okay, so the third thing we have is what we call fixed, and I like to think of this as the diving board. Okay, we're going to show it kind of like that, a wall that's right there and it's cantilevered out. Okay, so if we think about a diving board, if you were to stand here on the diving board, you realize that it kind of comes down like that as you bounce on it. Okay, it stays perpendicular to the wall. If you're standing on the diving board, then we have to have that y component pushing up, or else the whole board would translate down. Sum of the forces equals 0. If I'm in the water and I've got my arms up on the diving board, and maybe I'm pushing or pulling on that diving board, again, we can have some sort of reaction in the X. We're preventing translation. And if I jump on that board, jump, 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 okay, we can see that the board has some deflection down here at the end where I'm standing, but there is zero rotation occurring at the wall. If this were pinned, then this would just be like a door hinge, and we don't want that. That would not work as a diving board. It would just hang down to the ground, okay? So it's fixed. There's zero rotation because we have this internal moment coming around that's like pushing it back up to stay in place. Okay, so we would say we also have a moment. We could call it a moment a day. Okay, so that's our three unknowns. So again, 3 reactions: roller, pin, fixed. 1 unknown, 2 unknowns, 3 unknowns. Okay? Simply supported can be a system that's a pin and a roller, or simply supported can be a system that's a cantilever. 1, 2, 3. 1, 2, 3. You have to have 3 unknowns or it's not stable. Now, when we look at beams a lot, we look at vertical loading. So this X component is 0, but it's only 0 because of the loading that we have. Okay, so we need to always recognize that we might have to say that A of X equals 0 because it could happen if we changed our loading. Reactions. The next video, we'll talk about equilibrium so that you can set up and solve problems.